What if the greatest mystery in the universe is not something far away in a distant galaxy, but something hidden in plain sight? For centuries, humanity has stared into the night sky, believing we were slowly uncovering the secrets of the cosmos. With every new telescope, every space probe, every discovery, we felt closer to understanding the grand design of reality. We discovered galaxies beyond imagination, black holes that devour entire stars, invisible matter that shapes the universe, and a cosmic beginning that occurred nearly 14 billion years ago. Piece by piece, the universe began to make sense, or so we thought. But recently, something unsettling has begun to emerge. The deeper scientists look into the cosmos, the more they encounter strange patterns, unexplained signals, and structures so vast that they challenge everything we thought we understood about the universe. Some discoveries are so strange that even physicists struggle to explain them. Others hint at possibilities that sound more like science fiction than science, and a few suggest something even more disturbing, that the universe may not be as simple or as random as we once believed. Imagine observing the ocean for the first time. At first, you see waves, tides, and currents, but then you notice patterns, strange rhythms, movements that seem almost intentional. Suddenly, the ocean no longer feels like chaos, it feels like a system. Now, imagine the universe in the same way, at the largest scales imaginable. Galaxies do not scatter randomly across space. Instead, they form enormous filaments stretching billions of light-years across the cosmos together. These filaments create something scientists call the cosmic web, vast network of galactic structures that connects the entire observable universe. But when astrophysicists began mapping this cosmic web with increasing precision, they noticed something deeply unsettling. The structure of the universe looked strangely familiar, not like a cloud dot, not like chaos, but like something we know very well. The structure of the human brain. Clusters of galaxies resemble nodes, filaments resemble neural connections, and the distribution of matter across the universe mirrors patterns found inside biological neural networks. 2 systems separated by unimaginable scale, yet sharing the same architecture. Coincidence? Perhaps. But this was only the beginning, because once scientists began studying the universe at deeper levels, even stranger mysteries began to appear. Signals from deep space that repeat without explanation, massive cosmic structures that should not exist, and regions of the universe that behave in ways that defy the laws of physics as we understand them. Each discovery raises a troubling possibility. What if the universe is hiding something? Not something small, not something distant, but something fundamental, something built into the very fabric of reality, something we are only beginning to notice. And if that is true, then our entire understanding of the cosmos may only be scratching the surface of a much deeper truth. Because the more we study the universe, the more it feels like we are not simply observing it, but slowly uncovering clues left behind by something far greater than ourselves. And what scientists discovered next would raise a question that may redefine humanity's place in the cosmos forever. Asterisk, for most of human history, the universe appeared silent. Endless space, endless darkness, endless stars. Ancient civilizations gazed at the sky and wondered whether the cosmos had meaning, or whether it was simply an empty stage where life appeared by accident. But modern science changed everything. When we first discovered other galaxies in the early 20th century, humanity realized something astonishing. The universe is far larger than we ever imagined. Our Milky Way galaxy alone contains over 100 billion stars. And yet it is only one galaxy among 2 trillion in the observable universe. 2 trillion galaxies. Each containing billions of stars. Each star potentially hosting planets. Each planet a possible home for life. Suddenly, the universe no longer seemed empty. It seemed overflowing with possibility. But this discovery created a question that has haunted scientists ever since. If the universe contains so many stars, so many planets, and so many opportunities for life, then where is everyone? This question is known as the Fermi paradox. And it may be one of the most unsettling mysteries in science, because statistically speaking, intelligent civilizations should be everywhere, even if life forms on only a tiny fraction of planets. The sheer scale of the cosmos should produce countless advanced civilizations, some older than humanity by millions or even billions of years. Civilizations capable of building megastructures around stars, colonizing entire galaxies, or sending signals across the universe. And yet, we see nothing. No alien probes, no galactic empires, no clear signs of advanced technology. The universe appears strangely quiet. At first, scientists assumed we simply hadn't looked long enough, but decades of observation have only deepened the mystery. Radio telescopes scan the sky for signals, powerful observatories search for artificial structures around distant stars. Space probes explore our own solar system for traces of ancient visitors. And still, the silence continues. But recently, something strange has begun to happen. Astronomers have started detecting anomalies in deep space, signals that repeat with unusual precision, objects that move in ways we cannot easily explain, and structures so enormous that they challenge our understanding of cosmic evolution. Some of these discoveries may eventually find natural explanations, but others remain stubbornly mysterious. And when scientists began connecting these anomalies together, a troubling possibility emerged. What if the universe is not silent? What if we simply don't understand what we are seeing? Because sometimes, the greatest secrets of the cosmos are not hidden in distant galaxies. Sometimes, they are hidden inside the patterns we have been observing all along. And once humanity began searching more carefully, the universe started revealing mysteries that no one was prepared to explain. But the story of how we reached this point begins thousands of years ago, long before telescopes, long before satellites, back when humanity first looked up at the stars and asked the question that started it all. And that question would lead us toward one of the strangest discoveries ever made about the universe. Long before satellites orbited the Earth, long before telescopes revealed distant galaxies, long before science began measuring the age of the cosmos, humanity already sensed that the universe held secrets. Thousands of years ago, ancient civilizations stood beneath the night sky and saw something that changed the way they understood existence. The stars were not random. They followed patterns, night after night. The same constellations appeared in the same positions. Seasons passed, and the sky shifted with predictable precision. To early observers, the universe felt almost organized. The ancient Babylonians mapped the movements of planets with astonishing accuracy. Egyptian astronomers aligned their pyramids with celestial bodies. Chinese skywatchers recorded strange guest stars that suddenly appeared and vanished. But perhaps the most profound realization came from ancient Greek thinkers, philosophers, like Aristotle and Pythagoras, began to ask a revolutionary question. What if the universe operates according to hidden laws? What if the cosmos is not chaos, but a grand system governed by mathematics? At the time, this idea sounded almost mystical, but centuries later, a series of discoveries would prove them right. In the 1600s, Galileo Galilei pointed one of the first telescopes toward the heavens and saw something humanity had never witnessed before. The moon was not a perfect sphere. It had mountains, valleys, shadows. Jupiter had moons orbiting it like a miniature solar system. And suddenly, the sky was no longer a divine painting. It was a physical universe. Soon after, Johannes Kepler discovered that planets follow precise mathematical paths around the sun. Then Isaac Newton revealed the force responsible for it all, gravity. For the first time in history, humanity realized that the universe was governed by invisible forces that could be measured, predicted, and understood. It was a breathtaking moment. The cosmos was not mysterious magic. It was a machine, a vast, elegant mechanism operating according to universal laws, or at least, that's what we believed. Because as science advanced, each answer we uncovered led to even deeper questions. When astronomers built larger telescopes, they saw stars far beyond our solar system. When those telescopes became even more powerful, they revealed something astonishing. Those stars were not isolated. They belonged to enormous star systems called galaxies, and beyond our own galaxy. There were countless others. Suddenly, the universe became unimaginably large. But something even stranger happened. The deeper scientists looked into space. The more they began noticing patterns that did not fully make sense. Gravity behaved strangely at galactic scales. Galaxies moved in ways that could not be explained. By visible matter alone, entire regions of the cosmos seemed influenced by forces we could not see. Scientists eventually proposed the existence of something mysterious, dark matter, an invisible substance that does not emit light, does not interact with ordinary atoms, but somehow shapes the entire structure of the universe. Today, we believe dark matter makes up 85% of all matter in the cosmos, which means everything we can see, every star, every planet, every galaxy, represents only a tiny fraction of what actually exists. The universe, it turns out, is mostly invisible. And if that revelation wasn't strange enough, scientists soon discovered something even more puzzling. The universe is not just expanding, it is accelerating. Something unknown, something powerful is pushing galaxies apart faster and faster. This mysterious force is known as dark energy. Together, dark matter and dark energy make up about 95% of the universe. Think about that for a moment. Everything humanity has ever observed directly, everything we understand about physics, everything we have studied for centuries, accounts for only 5% of reality. 95% of the universe remains fundamentally unexplained. It is as if humanity has been studying a vast cosmic puzzle while only seeing a few scattered pieces. And somewhere within the missing pieces, there may be answers we have not yet imagined. But, as astronomers began investigating these mysteries more closely, they stumbled upon something even stranger, something that did not simply challenge our understanding of physics. It challenged our understanding of whether the universe itself might be trying to tell us something. Because in 1977, a telescope in Ohio detected a signal from deep space. A signal so unusual that even today, no one can fully explain it. And that discovery would become one of the greatest cosmic mysteries ever recorded. Asterisk, on the night of August 15, 1977, something extraordinary happened at Ohio State University. A massive radio telescope, known as the Big Ear, was scanning the sky for unusual signals from space. The telescope was part of a scientific project designed to answer one of humanity's biggest questions. Are we alone in the universe? For years, astronomers had been listening carefully to the cosmic radio waves passing through space. Most of the signals were natural. They came from pulsar, quasars, or distant galaxies. But on that particular night, something different appeared. A signal, a very powerful one. It lasted only 72 seconds. But during those 72 seconds, the telescope recorded a burst of radio energy far stronger than anything the scientist had ever seen before. The signal did not resemble natural cosmic noise. It was extremely narrow in frequency, unusually clean, and appeared to come from a specific region of space near the constellation Sagittarius. When astronomer Jerry Emin reviewed the data days later, he was so surprised that he circled the signal on the printout and wrote a single word beside it. Wow. The name stuck. To this day, the signal is known as the WOW signal. At first, scientists assumed the signal would eventually repeat if it came from a natural cosmic source. It should appear again if it came from technology, perhaps even an alien civilization. It might send additional transmissions, so astronomers pointed their telescopes toward the same region of space. Again, and again, and again. Years passed. Then, decades, the signal never returned. No matter how carefully researchers searched, the mysterious burst of radio energy remained a event. Some scientists proposed natural explanations. Perhaps it came from a passing comet, or an unusual cosmic phenomenon we don't yet understand. But none of these explanations fully matched the characteristics of the signal. The mystery remained, and the WOW signal was only the beginning. In the years that followed, astronomers began detecting other strange cosmic signals. Some lasted only milliseconds, Others repeated in irregular patterns. One particularly puzzling phenomenon became known as fast radio bursts, or FRBs. These bursts release more energy in a fraction of a second than our Sun emits in several days. Some FRBs appear randomly, but others repeat over and over again, almost like beacons, even more mysterious. Certain bursts seem to originate from extremely distant galaxies, billions of light-years away. This means whatever created them must be unimaginably powerful. Some astrophysicists believe FRBs are produced by exotic objects like magnetized neutron stars. But not all bursts behave like magnetars. Some signals show patterns that scientists struggle to explain. And every time a new signal is detected, astronomers ask the same question: what exactly are we observing? Because signals are not the only cosmic anomalies scientists have discovered. In 2015, astronomers studying a distant star noticed something that seemed impossible. The star dimmed in a strange and irregular pattern, not like a planet passing in front of it, not like dust clouds. The dimming appeared chaotic, unpredictable, almost engineered. Some scientists cautiously proposed an extraordinary possibility. What if the dimming was caused by a massive artificial structure surrounding the star? A structure built by an advanced civilization to capture energy from its sun, a concept known as a Dyson sphere. Most astronomers remain skeptical of this explanation, but the fact that it had to be considered at all reveals something important. The universe continues to present mysteries we cannot easily explain. Signals from deep space, unusual cosmic structures, invisible forces shaping the cosmos. Each discovery adds another layer to the puzzle, and slowly, piece by piece, the mystery grows deeper, because the more we observe the universe, the more it begins to feel like we are only seeing fragments of a much larger story, a story written across billions of years, billions of galaxies, and perhaps civilizations we have not yet encountered. And as scientists continue exploring the cosmos, they are beginning to ask a question that once seemed impossible. What if some of these mysteries are not natural at all? What if the universe contains evidence of something far more advanced than humanity? Because the next discoveries would suggest something even stranger, that the universe itself may contain structures so enormous, so complex, that they challenge everything we thought we knew about cosmic evolution. And if those structures truly exist, they may point toward a possibility that is both thrilling and deeply unsettling. Something hidden in the vast darkness of space, waiting for us to notice. By the early 21st century, humanity had entered a new era of cosmic observation. Powerful telescopes orbited the Earth. Space observatories stared into deep space with unprecedented precision. Radio arrays scanned the skies night after night, listening for signals from the far reaches of the universe. For the first time in history, humanity was not simply observing the cosmos, we were mapping it. And as those maps grew larger and more detailed, scientists began noticing something strange. The universe was not structured the way we expected. On the largest scales imaginable, galaxies should have been scattered randomly across space, shaped only by gravity and the slow expansion of the cosmos. But that is not what astronomers found. Instead, galaxies appeared to organize themselves into vast interconnected structures stretching across billions of light. Gigantic filaments of matter linked clusters of galaxies together in a colossal network known as the cosmic web. Imagine a three-dimensional spiderweb spanning the entire observable universe. Along its threads lie enormous clusters of galaxies. Between those threads are vast cosmic void regions, almost completely empty of matter. This structure is so enormous that no human mind can truly comprehend its scale. But what puzzled scientists most was not the web itself, it was the size of the structures forming within it. According to current cosmological models, there should be a limit to how large cosmic structures can grow. Gravity needs time to pull matter together. But the universe has only existed for about 13.8 billion years. That puts a theoretical limit on how large structures could realistically become. Yet when astronomers began mapping distant galaxies, they discovered something that seemed to violate that limit. In 2013, researchers identified an enormous cosmic structure known as the Hercules Corona Borealis Great Wall. Its estimated size was almost unimaginable. Over 10 billion light-years across. To put that into perspective, our entire Milky Way galaxy is about 100,000 light-years wide. This structure was 100,000 times larger. It was so vast that light traveling at the speed of light would need billions of years to cross it. And according to the laws of cosmology, such a structure should not exist. It was simply too large. Scientists initially assumed the discovery must be an observational error. Perhaps the galaxies only appeared connected due to the way we observe distant space. But additional observations confirm something unsettling. The structure was real, and it was not the only one. Astronomers soon discovered other enormous cosmic formations: the Sloan Great Wall, the Giant Arc, and additional galactic alignments, stretching across unimaginable distances. Each one pushed the limits of what cosmological theory predicted. Each one raised a troubling possibility. What if our understanding of the universe's evolution is incomplete? Because if the universe truly formed after the Big Bang and evolved, according to known physics, these gigantic structures should not have had enough time to form. Something about the universe's growth might be missing from our equations. Or perhaps something even stranger is happening. Some physicists have begun wondering whether hidden forces or unknown cosmic processes may be shaping the large-scale structure of reality. But the mystery does not end there, because when scientists began studying galaxies more closely, they noticed another curious phenomenon. Many galaxies appear to rotate in the same direction, not just within clusters, but across vast regions of the cosmos. It was as if entire sections of the universe shared a common spin. Imagine flipping a coin trillions of times. Statistically, you would expect half of them to land heads and half tails. But what if nearly all of them landed the same way? That is roughly what astronomers began observing with galaxies. In some regions of space, galaxy rotations appear strangely aligned. This should not happen in a random universe, and yet the data suggests it might be happening. Some researchers propose that these patterns could hint at conditions that existed before the Big Bang. Others suggest our universe might have inherited motion from a previous cosmic cycle. But there is another possibility, one that some scientists hesitate to discuss openly. What if the universe's structure is not purely natural? What if something or someone once influenced it? At first glance, that idea sounds absurd. The universe is far too large for any civilization to manipulate. But as humanity continues exploring cosmic mysteries, the boundaries between science and speculation sometimes begin to blur. Because the next theory scientists began exploring would push those boundaries further than anyone expected. A theory that suggests the universe might not simply be a natural phenomenon, but something far stranger. Something designed or simulated by intelligence far beyond our own. For centuries, humanity believed the universe was a physical reality governed by immutable laws of nature. Stars formed, galaxies evolved, planets orbited their suns. Everything followed predictable rules. But modern physics has introduced an unsettling possibility. What if reality itself is not exactly what it appears to be? At the smallest scales of existence, the universe behaves in ways that defy common sense. Particles can exist in multiple states simultaneously. Events appear to be influenced by observation. Quantum entanglement allows particles separated by vast distances to affect each other instantly. These phenomena challenge our classical understanding of space and time. They suggest that reality may be more flexible and more mysterious than we once believed. But some physicists have taken these strange discoveries even further. They have begun exploring a radical idea known as simulation theory. The hypothesis proposes that our universe might not be the ultimate level of reality. Instead, it could be a highly advanced simulation created by an intelligence far more technologically advanced than humanity. At first glance, the idea sounds like science fiction, but surprisingly, it has been taken seriously by several respected scientists and philosophers. The reasoning is surprisingly simple. Human technology is already moving toward the creation of complex virtual worlds. Video games simulate entire environments. Artificial intelligence can generate realistic universes, and computing power continues to grow exponentially. If a civilization became advanced enough, it might eventually possess the technology to simulate entire universes populated by conscious beings. If such civilizations exist somewhere in the cosmos or existed in the distant past, then the number of simulated universes could vastly exceed the number of real ones, which leads to a startling conclusion. Statistically speaking, it might be more likely that we are inside a simulation than in the original reality. Some physicists have even suggested that certain properties of the universe resemble computational systems. For example, the universe appears to have a maximum speed limit, the speed of light. Some theorists compare this to a bandwidth limit within a computational system. Quantum mechanics also reveals that information plays a fundamental role in the structure of reality. Some interpretations suggest the universe itself may operate like an enormous information processing system. Of course, none of this proves we live in a simulation, but the idea raises fascinating questions. If reality is simulated, who created the simulation? Why was it created? And are we capable of discovering evidence of its existence? Some scientists have suggested that advanced civilizations might deliberately hide clues inside simulated universes. Others propose that anomalies within physical laws could reveal computational limits, but so far, no definitive proof has been found. Still, the idea refuses to disappear, because the universe continues to present puzzles that resist simple explanations. Gigantic cosmic structures that should not exist, signals from deep space we cannot identify, and physical laws that behave in strangely mathematical ways. Each mystery adds another layer to the question: is the universe purely natural, or something more? And as scientists push their instruments deeper into space, they are beginning to explore regions of the cosmos so distant and so ancient that they may hold answers we never expected. Because somewhere in the darkness between galaxies, there may exist civilizations far older and far more advanced than our own. Civilizations capable of engineering structures on a cosmic scale. Civilizations that might already understand the true nature of the universe. And if such civilizations exist, then the next stage of humanity's cosmic journey may reveal something far more astonishing than we ever imagined. Something waiting in the deepest corners of the universe. Something that could finally reveal whether the cosmos is hiding a secret far greater than we ever suspected. And that journey begins by looking beyond our galaxy, into the vast and mysterious ocean of galaxies that fill the universe. Beyond the quiet glow of our Milky Way galaxy lies an ocean so vast that even the most powerful telescopes can only glimpse fragments of it. For most of human history, our galaxy appeared to be the entire universe, a swirling river of stars stretching across the night sky. But in the early 20th century, astronomers realized something astonishing. The faint smudges visible in deep sky photographs were not clouds within our galaxy. They were entire galaxies themselves, each one containing billions, sometimes trillions of stars. And once humanity understood this, a new realization followed. The universe is unimaginably large. Today, astronomers estimate that the observable universe contains over 2 trillion galaxies, 2 trillion cosmic islands, each with its own stars, planets, and possibly civilizations. Some of these galaxies are older than our own. Some formed when the universe was still young. And somewhere among them, there may exist civilizations that began evolving millions or even billions of years before humanity appeared on Earth. To understand how advanced such civilizations might become, scientists have proposed something called the Kardashev scale. This scale measures civilizations according to how much energy they can control. A Type 1 civilization can harness all the energy available on its home planet. Humanity has not yet reached this level. We currently operate at roughly Type 0.7. Type 2 civilization would be capable of harnessing the full power of its star. One theoretical method of doing this involves constructing an enormous megastructure around a star to capture its energy. This concept is known as a Dyson sphere. Imagine billions of satellites or structures surrounding a star, absorbing its light and converting it into usable power. Such a structure would provide unimaginable energy, enough to power a civilization capable of interstellar travel. But the Kardashev scale does not stop there. A Type 3 civilization would harness the energy of an entire galaxy. Such a civilization might build megastructures around billions of stars. It might travel freely between star systems. It might manipulate matter and energy on a scale that, to us, would appear almost godlike. And here is the fascinating question. If such civilizations exist, could we detect them? Astronomers believe the answer may be yes. Megastructures around stars could create unusual light patterns, detectable by telescopes. Advanced civilizations might emit artificial signals. They might even reshape entire planetary systems. Some scientists have begun searching the sky for exactly these kinds of signatures, and occasionally, something strange appears. In 2015, astronomers studying a distant star known as KIC 8,462,852, often called Tabby's star, noticed something bizarre. The star's brightness dropped dramatically at irregular intervals, sometimes dimming by more than 20%. No known planetary transit could produce such dramatic fluctuations. Dust clouds could not fully explain it. Comets might account for some dimming, but not all. For a brief moment, some scientists considered an extraordinary possibility. What if the dimming was caused by a massive artificial structure orbiting the star, perhaps fragments of a Dyson sphere, or another type of megastructure built by an advanced civilization? Further observations later suggested that dust was the most likely explanation. But the episode revealed something important. Humanity has reached the point where we can detect potential signs of cosmic engineering. And if advanced civilizations exist, their technological footprints may already be visible in the cosmos. But megastructures are not the only possibility. Some theorists suggest that sufficiently advanced civilizations could reshape entire star systems. They might move planets, create artificial habitats, or even manipulate stars themselves. At that level of technology, the line between natural astrophysics and engineered cosmic architecture might become blurred. And if such civilizations have existed for millions or billions of years, their influence might already be written into the structure of the universe, hidden among galaxies, buried within cosmic signals, or embedded within patterns we have not yet fully recognized. But perhaps the most fascinating question is not whether advanced civilizations exist. The deeper question is, what happens when a young civilization like humanity begins approaching those same capabilities? Because the path from a planetary species to a galactic civilization may not be as distant as it once seemed. And the choices humanity makes in the coming centuries could determine whether we remain confined to one world, or become something far more extraordinary, a species capable of exploring the stars, and possibly uncovering the deepest secrets of the universe itself. But before humanity can reach that future, we must first confront a profound challenge. Our civilization is still fragile, our technology is powerful but incomplete, and the universe remains a dangerous place, which raises an unsettling possibility. Perhaps the reason we have not found advanced civilizations is not because they never existed. Perhaps it is because something prevented them from surviving long enough to spread across the stars. And if that is true, humanity may be approaching one of the most critical turning points in its entire history. Asterisk right now, humanity stands at the edge of a transformation unlike anything in our history. For thousands of years, we have been confined to a single planet. Every human civilization, every war, every discovery, every work of art has occurred on a tiny blue world orbiting an ordinary star. But that may not always be the case. In the past century alone, our species has taken its first steps into space. We launched satellites, walked on the moon, sent robotic explorers to distant planets, and built telescopes capable of seeing galaxies billions of light years away. These achievements represent only the beginning. Within the next century, humanity may establish permanent settlements on the moon. Mars could become home to the first interplanetary colonies. Asteroid mining may unlock vast resources floating through the solar system. And once we master living beyond Earth, the next frontier will be the stars. Interstellar travel is incredibly difficult. The nearest star system, Alpha Centauri, lies more than 4 light-years away. With current technology, a spacecraft would take tens of thousands of years to reach it. But scientists are already exploring new possibilities. Light-sail spacecraft, powered by powerful lasers, fusion, propulsion engines, antimatter drives, even theoretical warp technologies inspired by Einstein's equations. Some of these ideas may remain impossible. But history has repeatedly shown that technological barriers eventually fall if humanity survives long enough. interstellar travel may become inevitable. And once that happens, the destiny of our species could change forever. Humanity could spread across multiple star systems. New civilizations could emerge on distant worlds. Our species could eventually become a multi-star civilization. But as humanity expands into the cosmos, we will face profound questions. How should we shape our future? Should we terraform planets to resemble Earth, or adapt ourselves through genetic engineering to live in alien environments? Should we build artificial habitats in space, gigantic rotating structures capable of housing millions of people, or even millions of species? Some scientists believe our descendants may eventually evolve into forms we would barely recognize. Biological humans may merge with artificial intelligence. Cybernetic enhancements may allow humans to survive in extreme environments. Consciousness itself might eventually exist in digital form. A future civilization might not be limited by biology at all. Such a civilization could explore the galaxy in ways we can scarcely imagine. Self-replicating probes could spread through space, carrying knowledge and technology across thousands of star systems. Advanced artificial intelligence could manage vast interstellar networks. Humanity or its descendants could become a cosmic presence. A civilization measured not in centuries, but in millions of years. But there is also a darker possibility. Many scientists studying the Fermi paradox have proposed something known as the Great Filter. The idea suggests that somewhere between the birth of life and the emergence of galactic civilizations lies a barrier, a stage so difficult to overcome that most civilizations never survive it. Perhaps intelligent life tends to destroy itself through war or environmental collapse. Perhaps advanced technologies eventually create risks too, dangerous to manage. Or perhaps there are cosmic dangers we have not yet encountered. If the Great Filter lies behind us, humanity may be re-rand incredibly fortunate. But if it lies ahead, then the coming centuries could determine whether our species survives long enough to reach the stars. And this raises a haunting possibility. What if the silence of the universe is not simply a mystery, but a warning? A warning left behind by civilizations that once reached for the stars, but never made it. Yet even this possibility may not represent the deepest secret hidden within the universe. Because, as scientists continue studying the cosmos, they are beginning to explore an idea that could change the way we understand existence itself. An idea suggesting that humanity may not simply be observing the universe, but participating in something far larger than we ever imagined. And that possibility leads us toward a question that may redefine our place in reality. What if consciousness itself plays a role in shaping the universe? And what if the ultimate mystery of the cosmos is not about distant galaxies, but about the nature of awareness itself? For centuries, humanity believed the universe was something separate from us, a vast stage where galaxies formed, stars burned, and planets drifted through the darkness. We saw ourselves as observers, small beings looking outward, into a cold and indifferent cosmos. But modern science has begun revealing something unexpected. The boundary between observer and universe may not be as clear as we once believed. At the heart of this mystery lies one of the strangest discoveries in all of physics: quantum mechanics. In the microscopic world of atoms and particles, reality behaves in ways that defy intuition. Particles can exist in multiple states at the same time. They behave like waves until they are measured, and somehow, the act of observation appears to influence the outcome. In one famous experiment, scientists discovered that particles traveling through two openings behave like waves when unobserved. But like particles when measured, it is almost as if the universe behaves differently depending on whether someone is watching. This phenomenon has puzzled physicists for nearly a century. Some interpretations suggest that observation collapses possibilities into a single outcome. Others propose that all possibilities exist simultaneously in parallel realities. But there is another, more philosophical question hiding beneath these ideas. Why does consciousness seem to play such an important role in observation? What exactly is the relationship between awareness and reality? Some scientists believe consciousness is simply a product of complex biological processes inside the brain. But others have begun exploring a more radical possibility. What if consciousness is not merely a byproduct of the universe, but a fundamental part of it? A growing number of researchers are studying theories suggesting that awareness might exist in some form throughout the cosmos. One of these ideas is known as panpsychis. It proposes that consciousness may be a basic property of matter itself. In this view, even the smallest components of the universe may possess extremely simple forms of awareness, not thoughts or emotions, as we experience them, but basic informational states that contribute to the larger fabric of reality. When matter becomes organized in sufficiently complex ways, such as in brains, these simple states combine to produce full consciousness. If this idea is true, it suggests something extraordinary. Human consciousness may not be an isolated phenomenon. It may be part of a vast continuum of awareness embedded within the universe itself. Another theory, known as integrated information theory, suggests that consciousness emerges wherever information is processed in sufficiently complex systems. Under this framework, awareness could arise not only in biological brains, but potentially in artificial systems, or even in large-scale structures of the universe. This leads to a fascinating speculation. What if the universe itself processes information? After all, the cosmos is filled with interacting systems. Particles exchange energy. Stars form and collapse. Galaxies merge and evolve. At every level, information flows through the fabric of space-time. Some physicists have even proposed that the universe might behave like an enormous computational system. If so, the entire cosmos could be viewed as a kind of information network unfolding over billions of years. But if the universe processes information, what is the purpose of that process? Is it simply the natural evolution of physical laws? Or could the universe itself be moving toward increasing complexity and awareness? Consider the story of cosmic evolution. First came the birth of space and time, then particles formed, atoms combined into stars forged heavier elements, planets formed from cosmic debris, life emerged from chemistry, conscious beings evolved, and eventually, those beings began asking questions about the universe itself. In other words, the universe produced creatures capable of understanding the universe. It produced minds capable of reflecting upon reality. Perhaps this is not a coincidence. Perhaps consciousness is the universe's way of exploring itself. Perhaps, through billions of years of cosmic evolution, the universe has been gradually awakening. And if that is true, then every conscious mind may represent a tiny piece of a much larger phenomenon, a distributed awareness spread across countless worlds and civilizations. A network of intelligence woven through the stars. Humanity might only be one small node in that network. But the implications of this possibility are profound. If consciousness is truly woven into the structure of reality, then the universe may not be silent after all. It may simply be communicating in ways we have not yet learned to recognize. And somewhere, in the vast darkness of space, there may already exist other minds asking the same questions we are asking now, looking up at their own skies, wondering about the same mysteries, searching for the same deeper truth. But to understand what that truth might be, we must take one final step back beyond galaxies, back beyond cosmic history, back to the ultimate question that has followed humanity since the beginning. Why does the universe exist at all? Imagine standing beneath the night sky on a perfectly clear evening. No city lights, no noise, only the silent glow of countless stars stretching across the darkness. Each of those stars is a sun, many of them surrounded by planets. Some of those planets may hold oceans, TMOs, continents, perhaps even life somewhere out there. Another civilization may be looking up at their sky at this very moment, asking the same question that has haunted humanity for thousands of years. What is the universe, and why does it exist? Despite all of our scientific progress, we still do not know the ultimate answer. We know how stars form, we understand how galaxies evolve. We can trace the history of the cosmos back nearly 14 billion years to the moment of the Big Bang. But the deeper mystery remains. Why did the universe begin? What created the laws of physics? Why does reality exist rather than nothing at all? Some scientists believe the universe may be one of many, a tiny bubble within a vast multiverse containing countless other universes with different physical laws. Others suggest the universe may cycle endlessly through periods of expansion and collapse. still others explore the possibility that the universe may be part of a deeper mathematical structure that gives rise to reality itself. Each theory offers fascinating possibilities, yet none provide a final answer. Perhaps the ultimate truth about the universe lies beyond the limits of human understanding, or perhaps we simply have not yet discovered the right questions to ask. But one thing is certain: humanity's journey into the cosmos has only just begun. We are a young species, living on a small planet, orbiting an ordinary star. Yet, in just a few centuries of scientific exploration, we have uncovered astonishing truths about the nature of reality. We have mapped distant galaxies, captured images of black holes, detected gravitational waves from colliding stars, and begun searching for signs of life beyond Earth. These achievements represent only the first chapter of humanity's cosmic story. In the centuries to come, our descendants may explore distant star systems, build civilizations among the stars, and uncover secrets about the universe that we cannot yet imagine. Perhaps they will discover other intelligent species. Perhaps they will unravel the mysteries of consciousness. Perhaps they will learn whether reality itself has deeper layers beyond what we perceive. Or perhaps they will discover that the universe is far stranger and far more beautiful than any theory we have created so far. For now, we remain explorers, standing at the edge of an infinite ocean of stars. Every new discovery reveals how much more there is to learn. Every mystery invites us to keep searching. Somewhere out there in the vast cosmic darkness, the universe may still be hiding something extraordinary, something waiting for humanity to discover. Because the greatest mystery of all may not be hidden in distant galaxies, but in the simple fact that the universe exists at all, and that within this vast and ancient cosmos, a small species on a tiny world has begun to ask questions about the nature of reality itself. Questions that may one day lead us to the deepest truth of the universe. Until then, the stars remain above us, silent, endless, and filled with possibilities beyond imagination.